There is a special case of use substitution. And I'm going to show you an example of that. If this was a problem, the integral of 2x square root of x minus 3. Normally, you would let u be x minus 3. Du would be 1. And that's all fine and dandy. But see, there's this extra 2x here. And the 2 is not a big deal, but the fact that the x is there, that makes a difference. Because since the x is there, there's not a way to get rid of it when we rewrite the problem. For example, if we rewrite it, we would have the integral of 2x square root of u du, and we have two different variables. So what we have to do is we have to rewrite x to make it in terms of u. And what we're going to do is we're going to use where we created u, and we're going to solve for x. So if u is x minus 3, we can add 3 to both sides, and then we get u plus 3 equals x. And then what you can do is you can come down here and plug in u plus 3 for x, and then you can solve. Now it looks kind of complicated to solve, but because square root of u is just one term, what you can do is distribute it. If you want to distribute the 2 first, that would be fine. And then you're going to distribute the square root of u. You're going to do it to that one and then to that one. And then you would end up with the integral of, let's see, u times square root of u. You would add those exponents, so that would be u to the 3 halves. And then 6 times square root of u, I'm going to write it as u to the 1 half. And then now I find the antiderivative. So the antiderivative of 2u to the 3 halves, if I add 1, that would be 5 halves, so it's u to the 5 halves. Flip it, and then multiply by the 2 in front. And then we have the 6, add 1 to the 1 half, so that would be 3 halves. So flip it. And then you're going to substitute back in what u was. So you would have 4/5 times x minus 3 to the 5 halves plus 12/3 or 4 x minus 3 to the 3 halves plus 6. The only time you use this case is when there's no other possible thing that you could use for u, and when what you have left over has like an x term. It can be multiplied or added by something, but as long as it's not, if it's x squared or something like that, there may be another way to do the problem. Okay, let's look at another one. Think about what you would normally let u be. U is going to be t plus 1, because that's what's on the bottom. It's what's underneath the square root. So du is 1. And what that does is that leaves us this extra t on the top. So that's where I have to rewrite this up here to solve for t. So I'm going to subtract 1. That's what t is, so then now I'm going to substitute it in. Now I have all u's, so I can solve the problem. Now I'm thinking about the antiderivative. So in the last problem we distributed. On this one, that's where you divide each one by the thing. So it would be like u over square root of u minus 1 over square root of u. So subtract exponents, that would be u to the 1 half minus u to the negative 1 half. If you bring it up and then multiply, that's okay. That's just not normally the way I would do it. So then the antiderivative of u to the 1 half, you add 1, so that's 3 halves. So then that would be 2/3 u to the 3 halves. Okay, minus, okay, add 1 to the 1/2, that would be to the negative 1/2. So that'd be 1/2, and flip it, so that would be 2. And then plus c. And then substitute back in what u was. Last example of this kind. It's basically the same. If you want to try it first, pause the video and then come back and see if you did it correctly. That would be fine. It looks longer, but it's the same kind of problem. U is going to be 3 minus 2x. Du is negative 2. On this one, you do have to put in a negative 2, take a negative 1/2 out, because we still need that to happen. But we still have that extra x. So this would leave us with negative 1/2 integral x plus 7 cube root of u. So I still need to know what x is. So I'm going to solve right here for x. I'm going to subtract 3 and then divide by negative 2 to get x. Now, it'd probably be easier to rewrite this one as u over negative 2 plus 3 halves. I just divided each by negative 2 plus 7, because we're going to have to distribute that cube root of u, and I think it would be easier to distribute whenever you separate it like that. Alright, u over negative 2 times the cube root of u. That would be adding the exponents. That would be 1 plus 1/3. So I'm just going to bring out the negative 1/2 and make it u to the 4/3. So that was that times that. And now I'm going to do this one times this one, so that would be 3 halves, no u to go with it, so u to the 1/3. You could go ahead and add the 3 halves and the 7 if you want to make it easier. 17 halves. So that's just 17 halves right there. And then multiplying by the u-thirds. And now find the antiderivative. So this negative 1/2 is just going to come on the outside of everything. When I add 1 to the 4/3, you get 7/3. So it's times 3/7 u to the 7/3. Add 1 to the 1/3, so that would be 4/3, so that's times 3/4. Alright. So I've got negative 1/2. I've got negative 3 over 14. U is 3 minus 2x. Alright, so then that's 17 over 2 times 3 over 4. I think it's 51 over 8. And then don't forget our plus c.